The James Webb Space Telescope has once again pushed the boundaries of what we thought possible. This time, it has delivered something extraordinary, an unprecedented look at the interstellar visitor known as 3I Atlas. For decades, astronomers speculated about objects that come from beyond our solar system, crossing briefly into our neighborhood before vanishing forever. With Webb's precision and clarity, that speculation has turned into direct observation, and the results are nothing short of astonishing. 3I Atlas was first spotted by ground-based surveys, its trajectory unmistakably hyperbolic. Unlike asteroids or comets bound to our Sun, this object was on a one-way journey, confirming its origin in another star system. For scientists, this realization alone was remarkable. But until Webb's instruments locked onto it, our view was limited to faint smudges of light, just enough to confirm its presence, but not enough to reveal its secrets. Now, thanks to Webb, we are seeing details that transform our understanding of interstellar wanderers. Unlike the elongated and mysterious Oumuamua, or the clearly comet-like Borisov, Atlas shows a mixture of both traits while hinting at something entirely new. Its shape, its brightness, and the subtle traces of gas venting from its surface challenge the neat categories astronomers once used. Webb's infrared instruments reveal fine dust trails, volatile compounds, and even faint envelopes of material shedding as it warmed near the Sun. Every pixel carries data about composition and texture, allowing scientists to study its chemistry in ways never possible before. One of the most exciting findings is the detection of carbon-bearing molecules and water signatures. These ingredients are similar to those in our solar system's comets but appear in unusual ratios. That difference suggests Atlas was formed under conditions not found here, making it a direct messenger from another planetary nursery. Its dust and ice carry the fingerprints of a system that may have formed planets long ago, and now, through cosmic chance, a piece of it has wandered into our skies. This discovery carries profound implications. Interstellar objects like Atlas are not just curiosities, they are emissaries. Each one represents the chemistry and history of a distant star system, offering us a sample without needing to travel light years away. To capture an image of such an object, to see it not as a streak of light but as a tangible traveler, is a rare scientific gift. Webb has given us a chance to study in exquisite detail something that will soon disappear back into the vastness of interstellar space. The comparison with Oumuamua is inevitable. That first interstellar visitor puzzled scientists with its unusual acceleration and odd shape, sparking theories that even included alien probes. But Webb's detailed view of Atlas narrows uncertainties. Its outgassing and brightness patterns behave as expected for a volatile rich body. While this rules out the stranger speculations, it still leaves us with new mysteries. Atlas doesn't neatly fit the mold of any known class of object, suggesting the diversity of interstellar debris is far greater than we imagined. There's also a practical side to this. If interstellar visitors pass through more often than we once thought, then understanding their composition and behavior could one day inform planetary defense strategies, or even future missions to intercept them. Imagine a spacecraft sent to meet an object like Atlas in flight, collecting samples forged around another sun. The data Webb provides today lays the groundwork for designing such missions tomorrow. But beyond science, there is something deeply human about this discovery. To see an object that began its journey around a distant star millions of years ago, now captured in vivid detail by a telescope orbiting a million miles from Earth, is profoundly moving. It reminds us that the universe is not just distant galaxies billions of light years away. It is also right here, passing briefly through our own skies in the form of travelers like Atlas. Webb's ongoing monitoring of Atlas will continue as it drifts farther from the Sun. By watching changes in brightness, gas emissions, and dust activity, astronomers hope to uncover its spin, internal structure, and perhaps even its origin. Whether it was flung out by a giant planet in its home system, broken off from a larger icy body, or formed under entirely alien processes, every clue brings us closer to understanding how planetary systems, ours and others, take shape. In the end, what Webb has given us is not just a scientific dataset but a glimpse into a cosmic connection. Atlas carries with it the raw materials of life, carbon, water, organics, that may be spread across the galaxy, delivered to countless worlds. It is a reminder that the building blocks of biology are not confined to Earth or even our solar system. They drift between stars, waiting for the right conditions to take root. The real image of 3I, Atlas captured by the James Webb Space Telescope is a landmark moment. It bridges imagination and reality, turning a fleeting visitor into a lasting symbol of our place in the galaxy. This is not just a cold fragment of rock and ice. It is a survivor of another world's story, carried across unimaginable distances to briefly meet ours. And thanks to Webb, we now have the chance to witness it with our own eyes. If you enjoyed this journey beyond our solar system, don't forget to like, share, and subscribe for more updates on the universe's most extraordinary discoveries. What do you think about 3I, Atlas and Webb's incredible capture? Let us know in the comments. We'd love to hear your thoughts.